So, you when we talked a few days ago, you said that you were trying to be in the office. You are in the office now.
Yeah,
Um, and because I got a little bit of feedback from one of my listeners, and he said, uh, don't show too much because I'm
yeah,
listening while I'm having a walk in on my lunch break. And I
yes,
told him, please don't feel triggered if you hear something like, "Oh, now I'm showing you my lab."
yeah,
Just ignore it. We're trying to be very descriptive, and if you feel that you're missing out, there's always the option to come back to the video and watching the video. So that helps me for getting views, and you,
yeah, for sure. Yeah, you hear that on podcasts a lot too, where sometimes they kind of do, also just kind of try to be more descriptive, right? Where you're like, here's, for people that are listening, here's what we're looking at right now, just so because I understand that feeling too. I listen to podcasts in the car a lot, right? So you shouldn't be watching video in your car.
yeah,
But
obviously.
yeah, yeah, but yeah, you kind of feel like you're missing out. But yeah, exactly. You always have that option to go back. But yeah, yeah. I thought I would just kind of sit in the shop. I mean, it's a question. I mean, we could, I mean, maybe it's even a separate thing, or I could send you some B-roll footage too of just walking around the shop a bit too and explaining or showing the different machines and stuff. But I know that's kind of not the focus of the podcast either, so that's fine. Yeah.
No, I'm happy that you took the advantage of sitting in the lab, sitting in the studio, because then whoever who wants to can has a have a look at, and I would love to you maybe showing something, if not just as fine. I think this is
Mm-hmm.
just one of hopefully many episodes to come, and we already talked about having an episode with you and Rob Knight, who was so
Yeah.
kind and being on an
Yeah,
episode before.
be a lot of fun. The sort of AI AI evangelist versus AI skeptic episode might be a fun one.
Mm. I mean, Rob was actually the one who took us with him in his lab. So the
Mm-hmm.
feedback came from his episode. So I said, dude, don't get triggered when you're listening to this.
Yeah.
Whenever you have time, take out the mobile phone. Yeah, but Trent, maybe we can start and go a little bit back. And Rob had a little bit trouble of getting all the dates right, so don't worry too much about it. But I really would like to understand. So where you're coming from. So what is the background? What is your background, and how you came in contact with robots and
Mhm.
engineering in general? And yeah, tell us a little bit about the design shop. It would be nice to, yeah, just to get to know you a little bit. And
Sure.
because there's a lot of people out there who would like to go into robotics, who are starting with engineering, and they're still unsure where to go and what to do. And yeah.
Yeah, exactly. Yeah, no, I'm looking forward to it too because I think my story is a little bit different than most roboticists or how most people got to robotics because just because of the nature of the shop and the way things have evolved here, it was a different entry point than maybe a career roboticist or someone who's done a PhD or that type of stuff. So hopefully it's interesting to people. Yeah.
Yeah, let's just jump right into it. So when you said that you have a different background or a different story, what makes it so different?
Well, I came out of, really pure software background. So I'm a computer scientist by training. I spent the first 15 years of my career in the entertainment industry, actually making video games and
Mm.
doing 3D graphics and rendering and audio and stuff like that. So that was sort of my background. It
And when
ended
was
up
that?
that started. So I got my first games job in 1996 at Electronic Arts, EA Sports. So
Mm.
worked on those titles. I think lots of people are probably familiar with the NHL and FIFA and NBA basketball and some of those things. I worked on Need for Speed. So lots of entertainment industry sort of background, which is interesting. It's sort of tangent onto itself, which is an interesting thing to explore. But I would say that industry is interesting because there's so many different disciplines. The games have physics and AI and gameplay, and then there's performance and GPUs and programming. low-level code, and all those things kind of wrap into it. And so people take different things away from that business. Tended to be involved in the low-level stuff, the graphics optimization, GPU programming and stuff. I was there for the first, NVIDIA boards and the 3D effects boards and things that came out in the very beginning. So that kind of planted that seed of just sort of GPU and graphics and that type of thing, which is the thread that probably stuck with me for my entire career, and even into robotics and things like that. Those skills have been incredibly relevant, but I came from the software side as opposed to the hardware side.
I have a few friends that are actually really into gaming, and so I'm asking these questions maybe in their favor, but I'm interested as well. I've done a little bit of gaming in the 90s when I was a kid. So you just mentioned those games, right? So NBA was something I was playing on computer back then, or the first Need for Speed, or not the first one, but Need for Speed on PlayStation actually.
Yeah.
And nowadays, and in the company I'm working for as well, and other companies, people are working remote, right? So they're sending files back and forth. They're working on an international level, and they're working remote with different kind of asynchronous communication. But if you have if you would like to, I would like to hear some stories about how was it working on these kind of games, like back in the 90s when there was no.
Yeah.
I sent you these huge files and we can talk on Zoom or on Skype or whatsoever. How was it to work on those teams where you're all on site, and how was it?
Yeah, it was wild. I think that was probably a much different era. Like in that day, it was still early enough that there might be dozens of people working on game as opposed to maybe hundreds today. And so you knew everybody, and the teams were really, really tight. And there was a really tight culture of just you were integrated with the content creators, the artists, the audio engineers, and it was a really, really tight loop where somebody could build new content in a day. And then I worked a lot on 3D pipelines and data management, so I worked hands-on with artists to then get their vision realized in the game. And this was something that you're all doing in real time. And we were building the engines for all these games too. It wasn't that you were using maybe Unreal or Unity or one of those products. It was all this technology every year was brand new. And so when new hardware came, there was a team of us that would, go figure out that hardware. We would get manuals from Sony, and we would kind of try to reverse engineer the Japanese. And this was way before we had Google Translate and tools
Yeah.
like that. So we're piecing through code examples and trying to make these machines work, and then trying to allow the content creators to realize their vision too on these new platforms. And so it was it was a lot more rock and roll then too. Like the parties and stuff were a little bit off the hook, and it was just a different time. It was a lot of fun, but it was also just an incredible amount of work. Like that was the culture of the 80-hour weeks and the really, really burning during crunch time and stuff like that. So it wasn't something that was maybe sustainable, but at that moment in time, it was pretty amazing. And I think everybody that came sort of out of that era of gaming probably has similar stories to tell. And yeah, it was a lot of fun, but it was pretty crazy.
You are located on the US West Coast, right?
Yeah, I'm in Vancouver, Canada, so
True.
west coast of Canada. Yeah, yeah. And we had, the West Coast's always been interesting that way. Vancouver's a smaller hub because Canada has always been a little bit smaller in tech, but this, sort of our proximity to Seattle and Microsoft and some of the big companies there means there's a lot of work, and there was a lot of crossover with Microsoft as sort of a key supplier of work and projects and stuff to us. um, Sony had presence in California. So then as you sort of move down the coast, you eventually hit Silicon Valley and then LA and the entertainment sort of hub. So yeah, so we had a lot of experience, I think, running up and down the coast and working with different companies in Seattle and California and so yeah, it was an interesting time. Although we were always a little bit segregated here in Canada. Yeah, I just see my lights are flickering behind me there. I'll try to keep them on so that we have good good lighting for the people that are watching.
Yes. Thanks. I mean, because I know another company that was, or I think still is, Ubisoft in Montreal, right? So this is on
Montreal.
the east coast of Canada, and actually, my wife, she was working for them, and she's from a totally different industry, but she was an ex-spin, so a German person working in Canada, and due to private reasons, and then she started working for this gaming industry and was looking into translations and helping them to translate those games. So very interesting. Thanks for doing this detour, or actually going through the path
Yeah.
that you went through. So what
Yeah,
happened
it's
afterwards?
definitely a fun time. Yeah, to think about. Yeah.
So what happened afterwards? Where you said so this was your first steps because you're on the software side. So how you
Yeah.
came in contact with
And
robotics?
this is where maybe the story gets even a little bit crazier. So, what happened after that, and the journey to robotics sort of took one more hop, which was 2008. The iPhone and mobile craze kind of started to hit, and I had always been a fan actually of smaller devices. So even towards the end of my gaming career, I was really focused on the portable devices, the Game Boys, the PlayStation portables, things like that. I loved the
Hmm.
small machines. That was my background. I started programming on a Commodore 64 when I was a kid. And so I was always nostalgic about small machines, right?
Hmm.
Um, when the iPhone came, I realized pretty quickly, I was like, I can do a lot with this machine. This is pretty wild. And at that time, there was a lot of work out there. There was contract work to build apps and do these things. And so I started a small consulting company just in the basement of my house doing mobile apps. And I thought, well, it was that dream. I'll be working for myself. I can kind of control my schedule and set some of my own terms and that kind of thing. Um, and it's a long story, but I really had no concept of how big that industry was going to become. And the fact that I kind of landed in the right spot at the right time. And so very, very quickly that company grew and things hit. We had iOS and sort of the iPhone initially, then Android came, then there was Windows Phone, there was tablets, there was there was even BlackBerry to a certain degree still in the mix, and like the whole thing just exploded. And so over the course of about probably the growth phase was maybe around 6 years. We really quickly ramped up, and pretty soon I had a company of about 160 people
Yeah.
building apps and mobile software. And then we started to look at different areas. And so we got interested in IoT, obviously, and sort of the hook there was that we were building Bluetooth devices. So we actually crowdfunded one of the first sort of Bluetooth beacon products because this all kind of drove business back into the software side as well. So we became experts at developing Bluetooth low energy devices, and that in turn generated a lot of interest in our software services around Bluetooth and accessories in the IoT space, to the point where we decided to spin up an internal startup sort of at my company. And I forked off to the hardware side to be working on the Bluetooth hardware and sort of the mechanical side. A lot of it involved sensors and enclosures and all the things that you would imagine for doing sort of industrial IoT. And that was sort of the next chapter or the next sort of evolution of my world, and worked a lot with electrical engineers. And I'm still by no means like a hardware expert, but I know enough to be dangerous now where I can handle myself. I laid out boards, like they coached me through the basics, and obviously I had professionals to double check and to do the real detailed work, but it was good enough to get an understanding of the whole system. And I wrote a lot of firmware, was sort of my specialty. And so um, the software side of that business just kept running, but I found myself more and more in love with the hardware side of the business. And so I kind of ended up forking, and I sold the software business to my business partner and to a bunch of the employees. So we did an employee purchase where a lot of the folks that had been with us for a long time had the opportunity to buy in and buy the company. And so they bought the software business for me, and I kept the hardware lab. And that sort of is where we're sitting today for anybody watching. But I'll describe it for those who aren't, which is, I I ended up pretty deep in the mechanical. I do a lot of CNC machining and 3D printing and product prototyping. I have some of the machines with robots to do machine tending to help me load and unload parts. And it's kind of a higher end, more boutique production, low volume production and job shop is maybe the best way to visualize it. I tend to pick and choose the products and projects that I work on, but it's set up to manufacture small batches of components or products, and really again, not to get too far ahead of myself, but during the pandemic, things shifted a lot because there was a lot of interest in parts and supply chain issues, things that couldn't be sourced locally anymore. So the machining side of things really heated up. I think as we're moving forward now, past that, thankfully, that stuff's slowing down, and so I'm using the machines more and more for prototyping and building robots, and a little bit less for production work and that type of business, but I still have the capacity to do both.
Yeah, I can see in the background you are. So you said that
Yeah.
you have a few machines. So what do you mentioned a few, you mentioned a CNC machine. What exactly do you have in your lab? So what are you working with at the moment?
So I've got, so you can see behind me, there's a small Haas machine. I've tended to focus on smaller machines. So I have a couple Haas mills, and then I have a small turning center, small lathe. I have laser cutter, a bunch of 3D printers, and a large table router. So that gives me the ability to process most materials that I prototype with. So I do, plastics, a lot of aluminum, some steel, some harder metals. But it's very, very flexible. The environment is set up so that if someone brings in an idea or brings in a product concept or a part or something that they're trying to do, 75% chance I've got something in house that can do at least the first prototypes of those or help iterate. That's the part of the process that I really like, is sort of the iteration phase, where it's like, hey, we're trying to figure out what this product is and how we're going to build a small number of these. There's better solutions when you're going to mass production, obviously, and that's when you get into the offshoring and everything like that. But I think what people neglect a lot is the value of the iteration and the cost of the iteration time up front. So if you can have a local ally that will help you get through that process and iterate quickly for you, you can really get a lot of work done in a short amount of time, as opposed to constantly having to do the design, send it out to be machined or to be manufactured, get the results back, realize where you failed, and then iterate. That can be, weeks or months even of iteration time. Whereas I feel the better solution is to find a resource that will partner with you on that, so that you can spin those iterations really tightly. And I think in a way, it actually goes all the way back to what I said about video games. The thing there too was the fact that we had the artists and the engineers and the people building the engine and the technology and everything all in a tight loop. And really, I'm just kind of doing the same thing with hardware, except that I'm rendering, I'm not rendering 3D graphics, I'm rendering parts in aluminum or in plastic. But honestly, conceptually, the idea is similar. There's a lot when you cross over into the physical world that you need to know, that's dangerous and difficult. But the concept is the same: is how can I help someone express their vision really, really quickly in a tight iteration loop, so that we can realize these products or these ideas faster.
I mean, it's great that you mentioned this, because a lot of founders, and I just read yesterday that founders are becoming builders now. So they're using a different naming. That this is actually most importantly, right? So you're sitting in your lab, you're sitting in your basement, wherever, and you're building a product without really understanding what are the needs of the customer and the user, right? So having this fast iterations give you the opportunity to make your product better, faster, and For example, this podcast I just started, you can buy a mic for a couple €100, and you can buy good light and good mic, so all the things that are necessary for having a very good podcast, right? Versus, is anybody listening to that podcast? Is there a need, and what are people are really interested in? So this is a video and audio podcast. Are people more interested in the video or more interested in the audio podcast? And buying those things. I mean, this is just an example now for this situation for me, but I see this at customer as well. So when you do simulations, robot simulations in a manufacturing site or in the plant, you can do a lot of things, but when you install them, right, then you see, oh, this is missing. The arm is too short. I mean, this would be really a beginner level mistake, but a lot of things that are necessary to actually produce something, right? And especially when you have
Yeah.
high volume or products that are very valuable and very hard to produce. I think your kind of shop offers an opportunity where people can bring their idea and form something, and then first understanding what is they actually need, what are the mistakes of them, and then making them better. Question that I have is, who are your customers? So what is the typical, how does your typical customer look like?
Yeah, it's a really interesting question. It's changed a lot over the years, and I think a lot of it has to do with where I am geographically.
Mm,
So, as we mentioned earlier, in Vancouver, uh, our primary businesses are, there's sort of resource-based industry, logging, and the traditional mining and that type of stuff. That's pretty heavy industry, and I do some work for some of those customers, but their needs tend to be very large, very industrial, very, dangerous and important type work, which isn't exactly what I do. The fit has been in, I'd say, two or three sort of main sectors. The one that I do a lot of work in is automotive, and sort of racing components and replacement components for older vehicles and things like that. That's been quite popular. The Vancouver has a pretty active food and beverage sort of industry. So, and I spent some time in the beer industry, which is another tangent, but I won't get into it right now. And so I have contacts from that, but work a lot on sensors and IoT products and things that are used in beverage production or food production, tends to be pretty big. And then the third area, and probably the most topical for us today, is robotics. So, Vancouver is home to a number of robotic startups and a community in general. I think that's quite interested. So supporting the tech industry is the other big one, and in that category is definitely robotics. But Vancouver also has a pretty active quantum computing sort of research and development community.
okay.
And so we see, interesting and unfortunately fairly NDA'd parts and challenges coming through from that industry. But it's a really good fit for me, because I think what those customers tend to find is that it's actually kind of nice to have somebody on the other side who's both involved in the mechanical, but also has the background in software and electronics and things like that. So it doesn't take as much time to explain the use case or what the application of the part is. I kind of have an intuition for that, so we can cut to the chase and just help develop the product instead of starting from scratch.
Thanks for giving the insights. And I am so I'm working for a robotic software company, and we enable robots to do things they cannot do on themselves or by themselves. So it's a vision system that you apply to a robot, and you can do this on a cobot or industrial robot. So we're working together with Universal Robots and Fanuc and KUKA, and we are looking forward to onboard other robot platforms depending on the need of our customers. And I think during the sales process, one of our sales representatives, they have the same problem. Customers would like to see use cases. Customers would like to see videos and pictures from production. Everyone would like to see, but no one wants to show, right? So we have big
Yeah.
German automotive and international automotive companies that we're working together with, and it's so hard to really get, especially because we are in the AI niche. It's very hard to get anything out of this NDA disclosure, and having pictures and videos helps for the not only for the sales process itself, but sometimes people lack of trying to imagine what you can actually do with the system, right? So we have a demo setup. It's a small UR3 that the sales guys are going to the customer and showing some demos. So I'm just saying this because I would love to hear some names. So I'm not 100% sure if you're able to drop some of your customer names. But yeah, first.
Yeah, I mean, actually, that's a really interesting cue on a project that I did spend a bunch of time on that I can talk about, and it's actually a really good example of that because you're 100% right. The big challenge is that a lot of this stuff is proprietary, and it's really hard to show, to make videos and to do things like that. And one of the things that has been nice about the shop is that I do run enough of my own product or enough of my own sort of test bed type machining operations, or sometimes I just do things for the sake of doing them, which I'm really fortunate to be able to do. And that presents an opportunity for me to make videos of things and to share things that maybe would otherwise be NDA'd or whatever, because it's like, well, hey, that's one of my products or a product I'm a partner on. I'm happy to show the machine making these things. It's absolutely a perfect use case for that. So I do demo and beta work for a lot of different companies, and one that was quite successful was I was a beta customer for Tormach for their new industrial arm. So they worked with me. So it was a really cool relationship because you're going in as a customer, but you're one of the beta customers. And so you're really part of the development process where you're feeding back and you're having weekly calls with everybody. And so we worked through all the use cases of getting their ZA6 industrial robot arm to do machine tending on one of the Tormach CNC machines. And it was an amazing project because it's a perfect example of like, hey, I've got a bunch of parts and I've got a bunch of real work that I need to do here, but that work is my own work. It's not NDA'd, so that's something that we can use as an example. So it's completely open for us to film robot videos of me trying to load and unload my parts and do the whole thing. So I'm showing how your robot works on practical parts in the lab. And the benefit is I own all of that, so we can show it all too, because that's okay. So that has been sort of a really sweet spot. We're also working on a new arm, which I'll hopefully be posting some videos shortly of, which is a really, really low cost robot arm, industrial arm. So it's much more lightweight, but it's going to come to market, at a really reasonable price point. And I'm working with a machinist named Mike Becker in Ohio, who has, a family machine shop, and they've been automating their own processes inside of the machine shop in a very similar way to mine. And that's another really interesting fit where Mike's happy to share his work. We've been open sourcing the code as we go. And the whole point of it being that we want to kind of democratize the low cost machine tending and that type of thing for a smaller machine shop or somebody that is just interested in learning about this to be able to do as well. So I mean, those are kind of the public facing customers we can talk about. The other folks, yeah, I mean, the Vancouver scene is really interesting. There's been a lot going on here, and it's hard to say. We've got great companies. I think we're going to see interesting things happening here, but it's, yeah, a lot of it is still, there's the public facing side of things, and then there's the back end of things, and it's difficult to avoid sort of mixing the streams.
I mean, what everybody is asking themselves. So last year was a big year for humanoid robots, right? So last year we had been seeing, and I'm repeating myself now over the episodes, whoever's listening more than one. We have a bunch of companies that are putting out these videos, and let's talk maybe a second, or as far as we can. There is a very famous robot company in Vancouver that is producing a robot called Phoenix. So this is
Yeah.
Sanctuary AI. They do have a
Yeah.
great podcast. I'm a huge fan. They both CDO and CEO are on Twitter. I follow them. Very interesting stuff that these guys are doing, and I'm really keen into see what they will pushing out this year. And do you? I mean, I just guess because you said this is a very small circle you're in. So I guess you're familiar with these guys, and
Yeah,
can you tell us something about it?
yeah, absolutely. I mean, Sanctuary's been very friendly to me, and I'm a huge, it's hard not to be a huge fan of their work. I personally think that Sanctuary is um, the most exciting Vancouver startup right now, if you can even call them a startup. I mean, that's become a fairly large effort, and I mean, I think as far as being in that race and the approach and sort of the pedigree of the people, Sanctuary is probably the kind of silent but deadly contender in that. You know what I mean? There's other companies that are flashier, and I mean, Sanctuary has a good social media presence, and I think what Phoenix has been able to do in the demonstrations and the sort of video series that they've produced has been really quite impressive. And it's kind of tough for me to watch, actually, in a way. The fact that people get so excited about Optimus and some of the stuff happening. I think Elon is maybe just a bigger media presence and so gets a lot of excitement about it. But realistically, the folks at Sanctuary have been doing similar demos for 2 or 3 years now, and the technology, like, we only see what happens in the video. So it's really hard to say behind the scenes how far along somebody is or isn't, because I mean, and it's been one of the things I've been a bit vocal on social media about lately is, I mean, I think, it would be super beneficial. I'm a proponent of the hashtag show the pilot, which is if you are teleoperating or you are, providing some human assistance or whatever, just show that. Just show that, because it's still an accomplishment. When you think about the dexterity of Optimus or Phoenix being able to, load and unload small objects or fold a shirt or all that kind of stuff, the fact that you can do that with human intervention, with controls and stuff like that, to me, is still amazing. And I don't think we need to cut the operator out of the scene and leave the question open as to whether that's a autonomous function or assisted function or fully teleoperated. Like, I just don't think we need to do that. And so anyway, my point being that I think Sanctuary is right there with everybody else, and they're doing really, really amazing things. And I think it'll be really interesting to see sort of, where this goes over the next couple of years. I think the problem maybe, or the elephant in the room, is that everybody's kind of waiting for the same thing. Like, we've got pretty elegant hardware now, and it's being demonstrated with teleoperation and doing things, again, like I say, that we're not possible. Not possible. Like, we take it for granted right now that there's a humanoid on YouTube and it's folding t-shirts, and that's okay. Oh, whatever. Well, it folds kind of slow. Well, I mean, let's rewind 10 years, and that would have been like from the future, you know what I mean? So we take it all for granted, but they're all lacking the same thing right now, which is that we haven't really seen the AI side deliver the goods on being able to, run with this stuff and do it autonomously. Like, we see amazing demos and we see amazing bits and pieces of reinforcement learning and planning and, integration and AI and LLMs describing, the tasks for a robot and all that. But it's very, very piecemeal, and it's certainly not, all interconnected and well integrated and happening in real time, in undefined situations and all those things that need to be true. So I'm interested to see where the companies all get to, and if somebody makes the breakthrough on that side, then we're going to see all of these robots become incredibly useful incredibly quickly, and that will include Phoenix and Optimus and Digit, and they're all amazing. They're all amazing products, right?
Just a couple of days ago, I had a talk with my boss, no, with my boss, with my former CEO and founder of the company I'm working for, Micropsy. So we are chatting about this, and every now and then I'm sharing some articles or videos with him, and because he's in the game for so long, he knows what is possible and what is not possible. And just as you said, there's still a lot of difficulties and challenges. And just a few days ago, Figure announced their partnership with BMW, right? And so if you have a big automotive, it can't get any harder than that, right? The requirements that automotive has is among the highest you can have, and the reliability and the accuracy, all those. So he said, if let's bet. He said, I give you a bottle of champagne if Figure will be able to deploy a or functional humanoid robot in a BMW factory. And we're not talking about a video from Gen Z that is showing some funny things, but really operating humanoid robot. This actually brings us to how we both came together, right? So one of the first things I saw when I entered this social media part, the robotics, I saw an open source project, and I had Rob Knight as one of my guests already in one of my episodes, but you are the other part of this Dex Hand. So maybe you can tell us a little bit about this project and how you've been involved with that. That would be awesome.
Yes, the Dex Hand is fascinating. It's my passion project right now. So I'll try to keep it all in a bundle here without going off onto too many tangents. So maybe I'll start with how I discovered it and what got me interested. So where I was going with this, and I mean, I think you can see behind me for those that aren't watching, I've got a UR3 with a Robotic 2 finger pincher gripper on there. That's sort of been the machine tending solution that I've used for loading and unloading parts, which is really, really common. Works great on rectangular or square parts. Works great loading material that's rectangular and square. It doesn't work as great if that part becomes an unusual shape inside the machine and needs to be unloaded. And so you run into all these limitations. And so I started down the path of wondering about different types of grippers. And obviously there's 3-finger grippers and other things that are sort of industrial. But my software brain said, wouldn't it be nice if I could turn this gripping problem into more of a software problem that where the gripper was kind of configurable and this and that and the other. And that kind of took me down the humanoid hand line of thinking, which was like, well, the one common feature of all these parts that I machine today is that I can unload them by hand. And so it's really interesting to think about that. I'm like, well, if I can unload them by hand, then why can't I have a hand to unload them? And so I started looking around for hands, and I'm like, well, and again, I was maybe fairly naive to the humanoid thing at that point. This was, a year and a half ago, which seems like forever now. I was like, well, I don't know. I've seen this on YouTube. It's all solved. There must be somewhere I can buy a hand. How much is this thing? Like $1,500 or whatever. And then, I'm going to get this hand and I'm going to glue it onto the end of the robot arm and I'll write a UR cap and I'll be able to control the fingers. And then I'll just change it into a software problem to be able to like shape the fingers to pick it up and load any part I wanted. But when I started down that road of discovery, I was like, holy smokes, this is not a solved problem at all, at all. And if I want to, even throw an ante on the table to play this game, I'm looking at probably 10, 15, 20, 30 grand for a robot hand that's basically an R&D item that probably will break. And so that was like, okay, well, this is not going to work. I'm not going to drop 30 grand to just see if this idea might be a thing. So I started looking around though, and I'm like, well, yeah, what's happening in open source? What's happening out there? And that was when I discovered Rob's projects. And I was like, wow, this is a thing, right? Like I could definitely, and especially, all the stuff we've just talked about in context, I've got a whole lab full of CNC machines and 3D printers and everything else like that. It's the mechanical side and actually manufacturing these parts to, you know, assemble a hand and stuff like that's easy. I just don't really know where to begin on that. And so that was when I discovered the open source project, and yeah, and basically just set out to build one to see if I could use it for work. So my spin on the whole thing is maybe a little bit different than the pure humanoid sort of research type thing. Is I've always been interested in, you know, I need a hand to do work because all my tools are built for hands to use. So that seems like the obvious, you know, interface to the physical world for what I try to do in my shop.
And so did you, because Rob has his own YouTube channel, so it's the Robot Studio, and but I think he told me that the website, this is actually something that you put on, and the software side, because there's obviously your expertise here. Um, so tell me how came you together so that you both were working on that project? So you saw this online, and then you said, let's talk to this guy. Let's talk to this guy, and so what were the next steps back then?
Yeah, that was exactly it. Saw it online. Let's talk to this guy. I mean, I think it started by me commenting on some of the videos on LinkedIn, just saying like, that's really remarkable. And Rob came back to me with like, do you want to try to build one? And I was like, yeah, of course I want to try to build one. You know, who wouldn't want to try to build one? But can I build one is maybe the question. So it worked out really well. And yeah, that was exactly it. What I discovered is Rob's passion and his design work is on the mechanical, on sort of the anatomical correctness. He's a very inspired designer, and those hands are, you know, incredibly realistic. And also for the V1 hand, the open source hand, the price point too, you know, it's designed to be built with sort of consumer grade servo motors and things like that. So it gives you an entry point to get there. When I built the hand, then of course the next question is, yeah, you know, hey Rob, so how, you know, how do I control it? What's been done? And that's where it got interesting, because there is, you know, he had the demos of using media pipe initially to just, you know, control the degrees of freedom and move the hand around. But from there, it's like, well, you know, what are you going to use it for? What's the application? Because that really dictates what the interface looks like and what this whole system looks like. And so that was when I really kind of engaged, because I was like, well, I have ideas about this. And realistically, back to what I said about hardware, the thing that I started to realize really, really quickly in all of this was, unfortunately, again, the limiting factor on this currently is the software and the control systems and the AI and the machine learning for, you know, doing grasping and all that type of thing. It just doesn't really exist. So in order to move this whole idea along, I needed to contribute to that part, because that was where my skill was. So I'm mechanically fine to assemble them, but realistically, I think it's going to be very, very important to answer those questions and solve those problems so that the hand becomes accessible to researchers and to people that can help move that state of the art forward on how you even control a dexterous hand and have it do meaningful tasks, right? So that was what I really started to invest in, and that took me even a little bit farther to realize that I think really what the world needs right now, or what we're trying to do with the open source project, is kind of provide that development tool or that development kit that allows people to even start approaching and solving these problems. Because I think there's a lot of power in sort of the community and having a lot more brains working on this. But right now, the barrier to entry, anybody that had the same idea that I had, which is like, hey, wouldn't it be neat to try a hand for this? We'll kind of run into like the same problem where there's like a lot of maybe toy hands, and then there's a lot of really expensive high-end hands. But in terms of accessible hands where you have a hardware, firmware, and software solution that you could actually go assemble yourself, I don't think there's as many projects like that. And so that's why, you know, we're trying to push that forward.
I'm very excited to see where this path leads us to. I'm looking forward to an episode that the three of us will be having, as a 10th episode anniversary. Um, no, I think you're totally right. These are things that needed to be solved by the community. So there's more than one brain involved into it, and all the different projects and experience that people had on their hobby sides or in their own labs, but on the university side as well. I mean, there's a few projects out there, as you mentioned, but especially when it comes to controlling the hand, there's not too many I've seen. And I think having a community or having a spot where people can go to download all the files, and as you said, you have a few 3D printers at your lab, and even a few I know a few people that have more than one 3D printer at home, right? So it's so accessible nowadays, and as you said, a few of the electronic parts are not overly expensive, so there is an entry point. What is the price point at the moment for the V1?
So the V1 you can build for under $300 right now.
Yeah, that is
So if you,
amazing.
yeah, if you've got the printer, you get the servos are just model aircraft servos inside of that hand, and so you can build a relatively dexterous, relatively capable hand for a few $100s. And then, Rob is gracious enough to share the CAD in an Onshape project. So you can go and start iterating as well, right? Which is sort of what I did. I took the initial designs and I was like, well, yeah, what happens if I take the fingers and I'll use my SLA resin printers to print them instead of my FDM machines? Okay, well, that's great. Well, I need to make some accommodations for, dimensions and for how the inserts and stuff work. No problem. I grabbed the source, I modified that, and then kind of went and optimized the hand to be produced on my equipment. And we've had other builders and students and folks like that do exactly the same thing, which is like they start off with the basic hand design, but there's a specific problem or a specific thing that they're interested in looking at, and so they take that design and go. And that's the beauty of open source. That's why that project is there, and it's really interesting to see what people do with it.
Can you give us a little insight in what we will be able to see in 2024 when it comes to the Dexhand
Yeah, so
project?
2024 is going to be an interesting one. Rob's been posting videos and they're out there. So we're actively in development of the version 2 of the Dexhand. And the way we're imagining the program to work right now is that, the current development version will be a closed source sort of commercial project to see that, we intend to make available to research labs and people that have a commercial application or are doing dexterous hand sort of research and development, grasping training, that type of stuff. It's intended to be fairly durable and something that would work in a lab where you can actually, in terms of early interest in it, it's been universities and research institutes who have found that the existing solutions are maybe a little expensive and a little brittle for when you go and you make that transition from sim to real. You're like, okay, well, I've gone from sim to real, and now I've just, had an error or just had a difference in training, and I've smashed my hand, and now there's a big RMA return process and stuff like that. Our concept is that this hand is still a moderate cost sort of product, and we're working through the details right now, but our intent is to kind of bundle it with a service plan, almost like a subscription, so that if you're actively doing research and it's important to keep your hand running and you smash it, there's a system where you report that. What happens is another hand from the shop here goes in a box and gets FedEx to you. You snap that onto your robot and keep going. You take your broken hand and you put it in the box and send it back, and it gets refurbished and put back into sort of circulation. So the hands are it's hands as a service, basically, where you're paying to have access to a working hand, right? And how
Hands
that
as a
business model
service.
plays
Love
out, we
that.
sort of have to see. But that's the gist for what we're doing right now. And the intent, though, is that every time we sort of bump a major version, someday when we go to V3, then the V2 will become the open source project and bump down. So there'll always kind of be an active commercial development happening and that's the big thing for 2024. And then as that sort of levels up, then that'll shift into the open source slot over time.
I think this is beautiful in terms of great that you guys are working on that, and especially the opportunity you just said. Always having a version that is open source and people can contribute to that and work with that on a affordable level is just great. I'm really looking forward for your project and how to develop, how it will develop and progress. I'm looking forward for the episode that we are having together, the 10th episode of this talk together with you guys. And I'm very glad that you took the opportunity and brought us to your lab and gave us a little bit of insight in how you came in contact with robots and what you're doing. And yeah, I'm very happy that I'm very happy that Rob is posting videos. I know actually I think the first video that I saw was your video, because there's a video where I think you connected ChatGPT to one of the hands, right? I think that was the first video that I saw, and I think I will use it as a promo for this episode here. So
yeah, awesome. Yeah, that was actually really fun because yeah, and worth noting actually too is that a big part of the work that went into the V1 hand and the software that's up there right now is to build out sort of basic ROS 2 support for it as well to make it accessible. And then the LLM demo was a function of hooking ChatGPT up to the ROS 2 interface to the hand and being able to answer questions. It was really fun. I mean, I'm surprised how well it worked. Honestly, I told GPT that the hand was an output device and it had an API that could control the finger extensions of each of the fingers. And then other than that, I just kind of said, if you can answer a question using fingers and gestures, do it. If not, tell me why. And started asking it questions, and it worked remarkably well for how minimal sort of effort went into that. So it was a really fun thing to share.
Yeah, and I'm so glad that I found it. I really enjoy talking to you, Trent. Thanks for taking the time. There's a time difference between Vancouver and Berlin, so it's still pretty early in your place. Thanks for being with us, and looking forward to have the chat with Rob. And really looking forward that you guys are finally giving out a date, because you're teasing a lot, but I'm really curious when the V2 will be available, and looking forward to, and we'll update everyone who is watching and listening.
Yeah, thanks so much. Yeah, we definitely appreciate the interest, and yeah, there's been so much good feedback from the community and from all the people that have seen the work. So that kind of keeps us motivated and keeps things rolling. And yeah, hopefully we work out all the details and have a product here pretty shortly. I think it'll be a really interesting upgrade over where we're at currently, and hopefully very useful to people trying to solve the problems that we need solved in order for this robotic future to happen.
Thanks, Trent. I'm really glad that you took the time, and looking forward to talk to you again.
Great, thank you.
Take care. Have a good one.
Okay.
Bye-bye.
Bye.